Welcome to the video on factoring polynomials by grouping. This video will focus largely on grouping. There will also be difference of squares, so if you haven't learned difference of squares, I would check out a video on difference of squares because I'm going to briefly cover that. But factoring polynomials by grouping is typically reserved for polynomials where there are four terms. And just because there's four terms doesn't mean that we can do grouping, but oftentimes, at least in my class, when I give you a polynomial with four terms, it is either not factorable or factorable by grouping. So the path that we're going to travel is, like all factoring problems, you should check to see if there's a greatest common factor to pull out. And in this case, all of our terms are multiples of 3, so I'm going to pull a 3 out of all of the terms first. The factor by grouping is going to be done on this four-term polynomial in the parentheses set. And what we're going to do is we're going to look at each pair and factor those. So we'll factor the first two and we'll factor the last two. So when I look at the first two, a common factor that comes out of both of those is an x squared, leaving behind 2x minus 3. And when I look at the second pair, the third and fourth term, a common factor that comes out is a negative 9. You'll know that you're on the right track if your parentheses sets match. If they do not match, then factor by grouping does not work, or you made a mistake. So if they match, then what you can do is you can pull that common factor to the front, and this leaves behind x squared and minus 9. And then you should always check to see if there's any further factoring you can do once you reach this point. And in this case, x squared minus 9 is a difference of squares. And so we can factor x squared minus 9 into x minus 3 and x plus 3. So this is our final factored form of the expression. Let's look at example 1b. Okay, 1b, start off, ask the self common factor. They all have a multiple of 2x, so we're going to pull a 2x out, leaving us with a four-term polynomial, and then we're going to try to factor by grouping on those four terms. Each pair can be factored. We can pull a 3x squared out of the first pair, and we can pull a positive 1 out of the second pair. Our parentheses match, so we're on the right track. We'll pull that parenthesis set to the front, and then we want to ask the question, can this be factored any further? And in this case, neither of those have a common factor that can pull out. There's no difference of squares, so that there is the final factored form, which I went ahead and wrote down here. Okay, let's look at example 1c. Here we have a of t, our variable is t instead of x. Looking for a common factor, I don't see anything that goes into all four of those terms, so there are no common factors, so we can just jump on down to the next step. We're going to factor each pair, and in the first pair a t squared comes out, and the second pair it looks like a 3 can come out. So t squared times 3t is 3t cubed. T squared times negative 4 is negative 4t squared. And then 3 and 3t makes 9t, and 3 and negative 4 makes negative 12. Then we'll factor the 3t minus 4 to the front, leaving behind a t squared and a positive 3. And then we want to ask the question, can we factor anything further from this? And there are no further factorings that you can do. So we are done with this step. I wrote it again there just for the sake of seeing it. Okay, let's look at example 1d. 1d. Got a four-term polynomial. Looks like there's x's in all of them, and it looks like they're all multiples of 5. So I'm going to pull a 5x out to the front, leaving behind 3x cubed plus x squared minus 12x minus 4. Then I want to ask the question, is there a common factor between the first two terms? There is. It's x squared. And a common factor between the second two terms, there is, and that's a -4. So we'll pull that common factor out, leaving behind 3x plus 1 in both cases. Because our parenthesis sets match, we're good. Pull that parenthesis set to the front, and then we want to ask the question, can I factor any further? And x squared minus 4 is a difference of squares, so we can factor that into x minus 2 times x plus 2. The shortcut on difference of squares is a squared minus b squared is equal to a minus b times a plus b. If you needed to use the AC method on that quadratic, you could do that as well. Okay, let's look at example 2a. Okay, 2a. Here we're introducing multiple variables, but it's still a 4-term polynomial, so we are going to try factoring by grouping. I don't see a common factor, so we'll jump right into factoring by pairs. It looks like in the first pair, both of them have multiples of 5x, and in the second pair, both of them have multiples of 8. So we'll pull out a 5x and a -8. This leaves behind 7y minus 1. Those match, so we can pull that to the front. And we want to check to see if there's anything else we can do to further factor each of those parenthesis sets, and 7 and 1 are relatively prime, 5 and 8 are relatively prime, so we're good. That's as far as it'll go. Okay, example 2b. X's and Y's this time. I think they're all even numbers. In fact, they're all even numbers divisible by 4. So I should be able to pull 4 out, leaving behind this polynomial. Then looking at the first pair, both of them have an x squared, and the second pair, both of them have a y squared. So when I factor each pair, my first pair, I'll pull the x squared out. Second pair gets the y squared. My parentheses match 2x plus 3 and 2x plus 3, so we'll factor that towards the front, 4 times 2x plus 3, leaving behind x squared minus y squared. X squared minus y squared is a difference of squares, so we can apply the difference of squares to that. Okay. 2 more, real quick. 2c. Looks like here we've got variables x, y, and r. Pretty ugly looking one. Probably the most challenging one that I would offer up. Large numbers also, but it looks like all of them are divisible by 3. So, oh, do they also all have an x? Yeah, they all have an x. So we pull a 3x out. Then I'm going to look at the first pair and see if there's anything that comes out. Both numbers are divisible by 8, and both of them have an x, so we'll pull an 8x. And then the second one, it looks like both of them have an r, so we can pull an r out. The end result is our parenthesis sets match, so we can continue with factor by grouping. Pull that 8y plus 3x to the front, and we're left with 8x minus r. Then we want to check to see if there's any further factoring. We don't see any difference of squares, there's no quadratics, and all of our numbers are relatively prime, so that's as far as that one factors. Okay, and for the final one, we're going to dive back into something with only x's. Example 2d. All numbers are even, so they're all divisible by 2, and they all have x squared in it, so we're going to pull 2x squared to the front. 4-term polynomial. 25x squared comes out of the first two, and -9 comes out of the second pair. So when we pull that to the front, the x plus 1 exists on both of them. We'll factor the x plus 1 to the front, and we're left with a quadratic, which is a difference of squares. So the final step is to factor that with the difference of squares. All right, there's your review video for factoring polynomials by grouping. Be sure to comment, like, subscribe, hit that bell for notifications, and have a good day.